Welcome to Sacred Echoes of India. In this segment, we are going to explore India's remarkable contributions to mathematics, showcasing the profound impact they have had throughout history. The country's intellectual traditions date back thousands of years, with early Indian scholars making discoveries and formulating theories that shaped the way we understand the world today. From the conceptualization of zero and the decimal system to advancements in astronomy, chemistry, medicine, and physics, one of the most significant contributions of India to mathematics is the concept of zero. The Indian mathematician Brahmagupta is credited with the formalization of zero as a number in the 7th century. In his work Brahmasputra Siddhanta, Brahmagupta introduced the rules for arithmetic operations involving zero, including addition, subtraction, and multiplication. The decimal system or the base 10 system is another monumental contribution from ancient India. This system was first documented in the 6th century CE by the Indian mathematician and astronomer Aryabhatta, whose works greatly influenced the development of mathematics and astronomy in both the Islamic world and Europe. The decimal system, with its place value system, made calculations more efficient and has since become the standard for global numerical notation. Aryabhatta was a pioneer in the field of mathematics and astronomy. He is best known for his work Aryabhattiyam, where he presented ideas on the rotation of the earth on its axis, and he calculated the value of pi to 4 decimal places. Aryabhatta's calculations of the earth's circumference and the length of the year were remarkably accurate. He also proposed the heliocentric model of the solar system long before Copernicus, suggesting that the earth revolved around the sun. The significance of Aryabhatta's work extended beyond mathematics. He was a key figure in the development of the Indian astronomical tradition. His contributions to understanding planetary motions and the treatment of eclipses laid the groundwork for later developments in astronomy. Brahmagupta, another important figure in Indian mathematics, made pioneering contributions in algebra, geometry, and arithmetic. His works were a continuation of the advancements made by Aryabhatta. Brahmagupta's rule for solving quadratic equations was revolutionary, and he also developed a concept of negative numbers and their operations, a groundbreaking idea for its time. Bhaskara I and his successor Bhaskara II furthered the work of Aryabhatta and Brahmagupta. Bhaskara II, also known as Bhaskaracharya, wrote the famous Lilavati and Bijaganita, where he tackled advanced problems in algebra, trigonometry, and geometry. His contributions to the understanding of sine and cosine functions were centuries ahead of their time. He also made significant strides in calculus, anticipating some of the concepts that would later be formalized in Europe. The Indian numeral system, along with the concept of zero, spread to the Islamic world through trade and scholarship. Indian mathematicians had direct influence on scholars in the Middle East, where their works were translated into Arabic. The famous Persian mathematician Al-Khwarizmi, whose name gave rise to the term algorithm, is believed to have been inspired by Indian methods of solving algebraic equations. These methods later made their way to Europe, where they revolutionized the field of mathematics. India's contributions to astronomy and astrology are equally impressive. The ancient Indians excelled in understanding the movements of celestial bodies and applied their knowledge to create sophisticated calendars. The Vedic texts contain references to the positions of stars and planets, which were used to determine the time for rituals and agriculture. During the Gupta period, the field of astronomy saw significant advancements. The Siddhantas, a series of astronomical texts, were written by Indian scholars, which laid the foundations for many ideas in both astrology and astronomy. The most well-known of these texts is the Surya Siddhanta, which detailed the movements of the planets, eclipses, and the calculation of time. The Siddhantas were influential not only in India but also in the Islamic world, where they shaped the development of early astronomical knowledge. Indian astronomers such as Varahamihira and Brahmagupta made contributions to understanding the solar system, the calculation of planetary motions, and the determination of auspicious moments for important events. Varahamihira's Brihat Samhita is considered one of the most comprehensive works on astrology, astronomy, and natural science. India's contributions to mathematics are both profound and timeless. From the revolutionary invention of zero and the decimal system in ancient times to modern advancements in space exploration and information technology, India has left an indelible mark on the global community. Thanks for joining us today. If you enjoyed this content, don't forget to like, subscribe, and hit the bell icon for more insightful videos. Until next time, stay curious and keep exploring.